An atom is made up of very small particles called subatomic particles. The main subatomic particles are protons, neutrons, and electrons. The protons and neutrons are found in the nucleus of an atom and are referred to as nuclides. Nuclides may have same number of electrons but different number of neutrons. Such nuclides are called isotopes. Isotopes have the same atomic number but different mass number. An element may have 2 or more isotopes. Radioactivity occurs at the atomic level when an atom has too much energy. Atoms with too much energy release that energy as radiation. Radiation is energy traveling in the form of particles or bundles of energy in a wave form. Some everyday examples of the energy bundles are microwaves used to cook food, radio waves for radio and television, light, and X-rays used in medicine. The table below shows a summary of some isotopes. From the table, it is possible to have an unlimited number of isotopes. Note that the number of neutrons vary from one isotope to another. However, as the number of neutrons becomes significantly greater than the number of protons, the nuclide becomes unstable and may disintegrate spontaneously. For a nuclide to be stable, the ratio of neutron to proton should be 1:1. Carbon-14 has 6 protons and 8 neutrons. The ratio of neutrons to protons is therefore 1:1.3. The ratio is significantly greater than 1, therefore C14 is unstable and likely to disintegrate. The unstable isotopes are referred to as radioisotopes. For the carbon-14 to gain stability, a reaction must occur within the nucleus. This reaction is called a nuclear reaction. Radioactivity is splitting up of an atom to form other nuclide and emitting particles, which are accompanied by the release of energy. Radioisotopes are isotopes that undergo radioactivity. Radioactive decay is the spontaneous splitting up of a radioactive nuclide as shown in the following animation. When unstable nuclides disintegrate, they form a new nuclei which may have different relative atomic mass and atomic number by emission of particles or energy rays. The spontaneous disintegration of unstable nuclides to form stable with emission of particles or energy rays is called radioactivity. There are 2 types of radioactivity: natural. This is exhibited mainly by isotopes of naturally occurring elements, usually with atomic number ranging from 84 to 92, polonium to uranium. Artificial. This exhibited by non-radioactive or stable isotopes after their nuclei are bombarded by subatomic particles, protons and neutrons. This is also referred to as induced radioactivity. There are 3 primary ways in which radioactive isotopes disintegrate or decay in order to attain stability. These are alpha emission, beta emission, and gamma radiation emission. Alpha contain 2 protons and 2 neutrons and have a double positive charge. It is identical to a helium nucleus and is represented as shown. The following equation shows an alpha emission. When an atom loses an alpha particle, the atomic number of the product formed is lower by 2, while the mass number is lower than 4. The following is an example of an equation showing alpha emission. Beta particles consist of fast-moving electrons. It has a negligible mass and a charge of -1. The mass number remains the same, but atomic number is increased by 1. It is identical to an electron. During the decay process, a neutron is converted into a proton and an electron. The number of protons in the nucleus reduces and an electron is emitted. It is represented as, in this reaction, carbon-14 disintegrates into nitrogen-14 by loss of an electron. The atomic number increases by 1 unit from 6 to 7 in nitrogen, but the mass number remains the same. The following is an example of an equation showing beta emission. This does not contain any particle. It consists of very high energy radiation, which are electromagnetic in nature and therefore has no mass or charge. The table below gives a summary of types of radiation and their charges. The type of radiation emitted by radioactive isotopes can be identified by its properties such as penetrating power, ionizing ability, behavior in a magnetic field, and behavior in an electric field. This refers to how far emission travels through air or in our bodies. Alpha particles are massive and travel slower than the others, hence have least penetrating power. They cannot pass through sheets of paper and travel shortest distance in air. Beta particles has some mass, though negligible, and travel longer distance in air than alpha particles. They can penetrate through sheets of paper but can be stopped by thin sheet of metal foil, for example, aluminium foil. Gamma rays have no mass, hence can penetrate through both sheet of paper and metal sheet. They can only be stopped by lead or metal block. Alpha, beta, and gamma are referred to as ionization radiations because they remove electrons from other elements, leaving the nuclei positively charged. Due to the slow speed, the rays are capable of ionizing oxygen and nitrogen gas more than the other emissions. Since alpha and beta are charged, they can be deflected by a magnetic field in opposite direction since they have opposite charges.